Hi, welcome back to Manohar Academy. In this lesson, we are going to learn about static variables. We are going to see what are static variables, why do we need them, and how they are different from member fields that we have seen so far. Before we get into those details, let's look at object characteristics that we have covered in the previous lesson. I am going to do a quick recap. So object has three characteristics, so namely state, behavior, and identity. Then we learned that two different objects can have the same state. Example, twins. So they look exactly same, they have the same state, same properties, but still they are two different people, so they have different identities. Then we said one object can have different states at different times. So whenever you change the values that are saved in the object, the state changes, but it is still the same object. So example, if you look at your photographs, you look different in different photographs, but we are talking about the same person with different states. Then we can compare two objects either by state or identity. This is a very important point, so make sure you remember that. Then instances of the same class exhibit same behavior because the behavior is defined by the member methods, and because we can invoke those member methods on every object of the class. If they are instances of the same class, they exhibit the same behavior. Lastly, the state of an object can affect its behavior. So this is also very important. For example, we cannot cancel an order that is already shipped. So these are the object characteristics. Now let me show you one simple program, but this is a graphical program. Here we have a graphical program. So every time I click on add ball, one ball will be added to this particular frame. And it will bounce, it will move, and whenever it hits the wall it will bounce. Let me add one more ball. As you can see here, the balls have different size, and let me add few more so you can appreciate it. And every ball is different. So here, now coming to identity, if I ask you how many balls are there, you will say 1 2 3 4 5 6. Total 6 balls are there, because every ball has its own identity. Total we have 6 balls. So coming to behavior, all balls are of the same instances of the same class, so they are all exhibiting the same behavior, that is either move or bounce of a ball. So instances of the same class will behave the same. Then coming to the properties or the fields or the state, each ball is of the same color, that is black, and they have different sizes and they have different coordinates, so they are all part of the object state. So let me write that. Okay, identity, we have 4 balls, so each ball has its own identity. Then coming to behavior, it is move or bounce, so it is exhibiting those behaviors. And coming to the state, this is very important because this lesson is about static variables and it has something to do with the state. So each ball has its own x coordinate, y coordinate values, so it's nothing but the position. Then they also have size, so some balls are bigger, some balls are smaller, and all the balls are of the same color, that is black. So if you see here, every ball has to have its own x value, y value, and size, but all the balls can share this particular variable, particular value, that is black. So whenever something is shared, we don't need to associate with the instance, we can associate this one with the class itself, because all instances are of the same color. So I don't need to mention every ball is black color. I can simply say this class, whatever instances are there, they are of the black. So let me write that in a program. So if I write a program called ball, so here you can see it has x coordinate, y coordinate value, and size. These are per instance. So if there are 10 balls, all the 10 balls will have their own values, but this color is shared across all the balls. So it is something shared. It is not at the instance level, but it is at the class level. But there is no keyword called shared. The keyword is static. So that is why we are calling them static variables. So as you can see here, static variables are nothing but the member fields, but they are shared. We will understand what we mean by shared. But if they are not static variable, we can call them non-static variables, or we can call them instance variables, because they are existing for every instance, not at the class level but at the instance level. So we can say that we have member fields and they are of two types. One is class variable, nothing but static variable. Okay, we can call them class variable also, or static variable. So we can either call them class variable or static variable. Also we have instance variables or non-static variable. So remember this, we have member fields which can be further classified into two types. One is static variable and non-static variable. Static variable also can be called class variable because the value is shared among all the instances, so it actually belongs at the class level. And another one is instance variable because they are saved in the object, so they are saved inside the instance of the class. So now onwards, I don't prefer to call them static variable and non-static variable, rather I will call them class variable and instance variable. Okay, so why do we need them? In this case, for example, in this particular case where we have balls, so if we have 1 million balls, do we need to save that color in all the balls? Because every ball has its own x value, y value and size. But do I need to save the same variable 1000 times, 100,000 times? I don't want to do that. I want to save that so that it can be saved at the class level. So there won't be 1000 or 10,000 instances of this one. So we are saving memory there. Also, they rightfully belong at the class level, not at the object level. Okay, let me show you one more example. Let me create one more class called student. Okay, this student is going to have first name, last name, and I'm not going to create any other methods. So let's simply make them, let's make a simple class, only first name and last name. So let me create the constructor. Then also let me, okay, for now it is fine, or let me create the toString method. Okay, I'm going to create 5 students or 4 students. Okay, I have 4 students. So now let me print those students. Okay, now we have those students. Everyone has the same last names for simplicity, and they are differing only by the first name. Now I want to create one more field called student ID, and this student ID I want it to be in the ascending order. So first student will get the student ID 1, second student will get the student ID 2, and so on. So I'm regenerating the toString method. Okay, now let me run the class, run this program. So here we can see all the students have 0 value. That is the default for this one, int. So now what I'm going to do is I'm going to create one static variable called next student ID, and I'm going to assign a value of 1. So at the class level I have a field which says next student ID is 1. Whenever I am creating a student, obviously I have to call this constructor. In this constructor, I am going to assign that values to the ID, student ID. So this way, every student will get the next student ID. So let me run this one. Now everyone is getting 1, but that is because I am not incrementing the student ID after I have used it. So let me increment that. So once I use the student ID, I am incrementing that one. So now if I run the program, it will print 1, 2, 3, 4. So that is where the variables will come handy. If we have to keep some information at the class level, then we can use these static variables. So this is how the program runs. When the class is loaded, before we can create any object, the class has to get loaded, and when the class is loaded, this variable will be created, but as I said, it's a class variable, so it will be at the class level, not in the instances, not in the objects. Anyhow, at this time we don't have any objects. So in the class object, this variable will be there. So when we are creating the first student object, this particular code gets executed. That student object will have 3 fields: first name, last name, student ID. First name and last name will be same as whatever we provide, but for the student ID, it will get the next student ID from the class, it will assign it, then it will increment that. So once the first object is created, next student ID will be 2. So you can create as many objects as you want. So if you are not able to understand here, let me show that with a proper diagram, not diagram, with a video. Okay, so as I said, before we create any objects, the class will be loaded and there will be one object called class object. It's not an instance of the class, it doesn't have those instance variables. It has only the static or the shade or the class variable, and the value is 1. Now let us create that first student object. So here I created the student object. In the constructor call, I have taken that next ID of 1 and I have assigned that ID to this particular student. So he got that ID 1 because that is the next ID available in the class object. Okay, as usual we have the reference, and okay, that reference will be pointing to that object, that is fine. But if you see here, at the end of the constructor call, we are increasing this particular variable, the class variable, by 1. So at this point, the next ID will be 2. It is no longer 1, it is 2. So you can observe that here we already used 1 and this become 2. Now let's create one more object. So we have created object. At this time, the next ID is 2. So that next ID is assigned to the student 2. So here the 2 is coming from here. So at the end of this particular constructor call, the value will change to 3. So if you observe here, the value become 3. And we have this student 2 variable that will be pointing to the student 2 object. That's just a detail. Now let's create one more object, student 3. Okay, now because the next ID is 3, it will have 3. Then the next ID will become 4 at the class level. Now if we create new object, that will get an ID of 4. So here we created new object, it got an ID of 4. Okay, then next ID will be incremented to 5. So here you can clearly see the difference between a class variable and an instance variable. All are member fields. Okay, whether we are calling it a class variable or instance variable, they are the member fields. But the static variables are here in the class object, and the instance variable, that is first name, last name and student ID, they are in the object itself, in the instance of the class. So if you can remember this particular diagram, then you can really appreciate the difference between static variable and instance variable. If we take the ball example, the ball will have x value, y value and the size here, and all the balls are of the same color. So here you will have a color equal to black. So instance variable, not instance variable, class variables save memory, as well as they give a common place to track the information that is at the class level, not at the object level. Okay, that is all about static variables. In the next lesson, we will look at static methods. We will see why we need static methods and what are the limitations of static methods, what are the advantages of static methods. That is for the next class. So once again, If you haven't subscribed already, please go ahead and subscribe. If you like this video, if you are benefited from this video, make sure you like it, you share it with your friends so that they can also learn, they can also watch. So once again, welcome back to Manohar Academy. We'll see you in the next lesson, that is the lesson on static methods.